All right, so we got a bunch of people still joining, but we'll kind of get ready to kick this off. So again, this is Vitrek going to present on cable test systems. My name is Don Milstein. I'm president of the company. We also have Glenn Broderick, our Western Regional Sales Manager. He'll be doing the majority of the speaking today. Really want to thank everyone for taking time to attend this webinar. Obviously, these are challenging times across the United States and the world with the COVID-19 epidemic. But I think it's wonderful that everyone, at least in our company, has been healthy, and we're excited about that. And hopefully, you and your family are the same way. What we've been able to do during this process is kind of look at ways to uniquely educate the marketplace. And these series of webinars has been one. So we're excited about that. If you go to the next slide, what you'll see is we just want to give you some contact information for both myself and Glenn, as well as the whole team, which you'll have at the last slide. And keep in mind, we will be sending this presentation out to everyone after the conference. So you'll be able to, so if you can take notes while you're doing it, great, but you'll be rest assured you'll have it emailed to everyone that attends, as well as it's being recorded, so it'll be up on our website. So if there's anything you wanted to hear, you'll be able to do that. But very excited about the opportunity and really appreciate everyone taking their time today. A couple of little ground rules on the next slide will show, we appreciate it. Looks like everyone has their mics on mute, which is wonderful. We have these little sections for questions throughout the presentation. And when we hit this section, we'll take a pause. You can open up your mic if you have a question. But throughout the session, there's a chat button that you can use, the chat feature to ask a question. We have people standing by to not only answer them in real time in the chat window, but we'll also be able to stop, take those chat questions, share it with everyone. So it's a good way. If you got a burning question that's killing you, go ahead, open up your mic and just jump in there. But if not, it's probably best to wait till we have these question section. So with that, I think we got, I'm sure people will still be joining, but let's go ahead and give you a quick overview on Vitrek itself. So Vitrek, as you know, is one of the leaders in high voltage for electrical safety testing for and all kind of measurement. The company's been around for over 30 years. Glenn, if you go back one slide, for over 30 years, we're headquartered in San Diego, California. Everything is manufactured there, so we're all American made. Yet we're truly a international company, right? We service, we have reps and distributors in over 30 countries. We sell throughout the world and all the different continents. So truly U.S. based, but with an international flair. We'll go into the products in a second, but just at a high level, it's really in that high voltage focus, right? High pot testers, electrical safety testers, cable test system, which is one of the main areas we'll cover today. Power analyzers, another key area, along with high voltage meters. And our facilities are all ISO 17025 accredited lab, so we can calibrate the products before they go out, obviously, and get certification, and then live with you as you go through the process over the years. If you need it to be recalibrated at any time, you just send it back and we can do that as part of our program. What I want to talk about next is really the industries we serve, right? It's kind of across the gamut, right? Semiconductors, whether they're manufacturing chips or components or PCB boards, anything like that, we're very involved. The lighting industry, heavy on the electric side, medical devices, aerospace, defense. And what was kind of interesting during this process, California shut, pretty much non-essential businesses down, but right away it was very apparent that we qualified under critical infrastructure. And we had our customers, whether it's in the medical field or the aerospace or defense military, came to us and said, please, we are critical infrastructure. We need you to support us. And we were able to do that. And I'm happy that our team stepped up. We obviously, like everyone else, anybody that could work from home did. And if not, we were running different shifts under the, proper spacing and, all the kind of sanitation, everything that we need, sanitary items we needed under the CDC guidelines, and we were able to keep our manufacturing in process throughout this time period. So that was good that we were able to do that. I'm proud of our staff for being able to support that. Go ahead to the next slide. From a customer base, it's really across the gamut. Whether in the consumer products, looking at refrigerators from Sub-Zero or computers from Apple. You also go into the commercial side where we have Boeing for airplanes and Siemens for medical devices, along with Philips. And then on the sustainability side, it's been one of the major areas that we've been focused on, both with Tesla Tesla electric vehicles and items like that. Climb just to the next slide on the customers and just stop there, please. We also deal a lot with the testing labs themselves, right? Whether it's UL, Lawrence Berkeley Labs, and truly a lot of the smaller labs around the country, even if they're built within the Air Force base or the military, and then the independent labs that are doing calibration. So all these areas fit our customer base. We're going to make sure anybody that's on the phone, just put it on mute if you could. It just helps. There's a little bit of background there. Let's go to the next slide for the products. So again, we're going to focus really on our cable test system, which incorporates our HiPod tester, which we have a full line of HiPod test products, along with a switch for automated testing. So, HiPod is probably the best known product for the Vitrek company throughout the years, really to test products, to make sure there's no electrical shock, right? Pretty simple. Each product going down a assembly line like a refrigerator toaster. Let's make sure it's safe for the customers and in compliance. We do a lot of work on the power analyzer side. We have a whole series of products, highly accurate, speed and capabilities to look at volts, amp bars, power factor, and much beyond that. Truly getting power efficiency for products. And this is used both, just like the HiPod testers, in the laboratory area, R&D labs, as well as on the production floor. One of our newer products is our digital DC load. That product is truly for testing power supplies and batteries, voltage, current, resistance. Really nice product for us and doing very well. And again, has some of the unique features. All of our products kind of operate at the higher end. That's really where we stand out, whether it's speed or accuracy at the top level that you need. And the last major category, I guess, is high voltage meters, which are truly looking to be used in the laboratory space, in calibration labs, used as standards throughout the world for testing truly high voltages, both directly and also with those Frankenstein-looking probes that you see at the bottom left-hand of that quadrant. So we point this out to show you that our company is pretty diverse in our products, all focus on the high voltage and energy side, both on the hardware as well as software, which we'll show you some of the software related to our cable test system. So with that, I will go to the next slide. Just stop here. If there's any questions, shouldn't be too many at this point. But then this is what you'll see off and on if we have a question through chat, or just if not, you can open your speaker. And it looks right now we're in good shape. So we'll go ahead. I'm going to turn it over to Glenn Broderick. He's our regional sales manager for the Western region. He's got well over 20 years experience in test and measurement, worked for quite a few of the largest companies in that industry, has been with us for the last few years. And with that, Glenn, I'd be happy to turn it over to you.
Thank you, Don. Thank you for everyone coming to the seminar today. This is going to be one of my favorite topics, which is cable and connector testers. And yes, I'm the Western Regional Sales Manager, but I worked for many years on a bench as well. And what you're looking at right now is some of the types of connectors and cables that we might end up testing with our products. And what you see on the left is those are MIL standard connectors. At one point, I worked in a QA lab, and I did the qual test for connectors like that. And it may not be obvious, but a connector like that. The tests take about 6 months for the qualifications. And when we get done, we have a book full of data that's maybe 1.5 inches thick. So you wouldn't believe the amount of tests that go into a connector like that. And a lot of those are electrical. Some of them are, we used radioactive isotopes to check the plating thickness, and but then the electrical tests were like the withstand test and the current test and so forth. So that's a mill standard connector. Over here is a typical cable. This is a pretty heavy duty one. You can see by the size of those connectors there, or the wires there, that it carries quite a bit of current. And over here on the right, what you'll see there is that's a big cable for deep under ocean mining. So this thing is actually about 5,000 feet long, and you can imagine the tests that go into that. Imagine high potting that thing, because every cable has to be high potted to all the adjacent cables. And so the test on that one, there's one test alone where they run these 5,000 pound weights on like a railroad track, small railroad track, and they run it out to the extension and basically slam the cable as hard as they can just to simulate what would happen in the ocean. And they do that 1 million times. That's how that cable is tested. So this is an electrical model, and it talks about anytime you're testing something like a cable or a connector, to the high pot, this is what it looks like. So it has a resistance, a capacitance, and a spark gap. So there is a resistance for continuity that goes through it. There's also a resistance that goes to the outer world. That's basically your leakage. There is a capacitance that at AC frequencies can be very significant. And as the voltage gets higher, you can have a breakdown. So this is a spark gap, and it represents the possible breakdown or arcing that can happen. So there's a lot of different types of measurements that can be done by a high pot, and in particular by this system. I won't go through each of them because we have other seminars that talk specifically about high pots, and the focus here today is on cable and connector testing. So unless you have specific questions on this, I'm going to skip this, and you can chat and ask questions about that if you like. This is some of the cable and connector compliance tests and standards. And when you get your actual slides, the PowerPoints, these are actual hard links to those specs, so that if you want to go in there, you can take a look at them. Some of them, like this Mill Standard 202G, they're going to charge you for that spec. Sorry, I can't give it to you because that is a charged item. But you can click on it and find a source for those. So there's a lot of test houses you see over here, like UL and TUV, and they do a lot of testing on things like cables and connectors to specs such as these over here. CSA as well, of course. Okay. So lately, there's been a big trend towards higher voltages, and you're going to find that what used to pass for successful testing is no longer acceptable. So in the old days, you might test a cable and connector at 1,500 volts. Today, you have to test at much higher voltages than that. Okay, so this is a typical cable and component test system. This is composed of our 95X series of high pots on the upper right here. And this is a 951i, that's the particular flavor of it, but we have about half a dozen of these different types. And it is coupled to a switch. This is a high voltage switch, high voltage, high current. And this is the front panel of the switch. And basically all you do is you wire the voltage hot to hot, return to return, and then here's all your outputs to your DUTs, okay? Now, optionally, this can be controlled by a piece of software called QT Enterprise, which I like because it makes running the system really easy, and we'll talk more about that in a minute. So the system may also include some other things. For instance, there may be an enclosure like you see right here. We do have these enclosures, and this is interlocked so that you put your DUT in here, the wires come in back here, and as you test, if someone happens to accidentally open up that enclosure, the high pot shuts off accidentally for safety reasons. Okay. This is what it looks like wired up. Again, hot to hot, return to return. You may have multiple chassis of these in the system. So each one of these chassis can have 1 to 8 cards. If you only want to have 8 outputs, you can just put in one card. But you can have 8 cards and have 64 outputs. And you can have many of these chassis in the system. We did one recently with about 12 or 13 chassis, and we had a company was testing 500 or 600 points. And we can do that. We can do it quite fast. In fact, they had looked at a competitive system and rejected it and said, hey, you know, they told us it could do it. In theory, it should have been able to do it. It would have been fast enough, but when we actually built it and tried it, it wasn't fast at all. We were able to go in and satisfy their needs with this system. Now, the outputs of these switches go into the back right here, into the enclosure, and your DUT. That's the way you would typically use that. So this is the 95X, and this is some of its capabilities. Essentially, on AC, we can go up to 6 kV. This model can go to 10 kV. Typical current is on the order of 50 milliamps. So other testers from other places may only have 5 or 10 milliamps of drive current. And where that becomes important is when you're driving capacitive loads, because if you don't have enough drive current, it may not get up to its test voltage very quickly or at all. Okay, so that's why that drive current's important. In fact, some specs require a 500 volt amp option. You can order that, and then we can give you 500 volt amps. And we can do it through this whole switch system. We can test, here's a 2 kV max option. It limits it. Instead of 6 kV, it's 2 kV, but look at the current. We can put out 4 times the current, 200 milliamps, okay? And we also have a 30 kV option. You can see right here. So that's on the AC side. On the DC side, we can do up to 15 kilovolts, and we can have drive current of up to 50 milliamps. This is the insulation resistance. That T stands for teraohm. So you know about megohms, that's 10 to the 6th ohms, and then you know about gigohms, that's 10 to the 9th, and then you have teraohms, which is 10 to the 12th. So this is a million ohms, a million megohms, and on this tester we can go up to 6 teraohms. Okay, so the system, depending on the unit you order, can also have ground bond. We have cards that can go in here that can handle up to 70 amps of current, so we can do ground bond testing with this system. And there is a 2-wire and 4-wire ohm meter built in, which is capable of resolution down on the order of 100 microohms. And so we can measure very, very tight resistances. This is a list of all the specs. I won't go through all of them. There's quite a few. But this is covered in our other systems on 95X, okay? Including safety features. There's a variety of ways for the user to abort the test or stop the test. I'm not sure that's a good word. We also have automatic stop, and that's basically being monitored all the time. The system's always monitoring itself. If it sees something that considers abnormal, it will shut down. It's all part of trying to make this safer for you so that you're more confident in the system, okay? Now, I said we can put 8 cards into the system, and there's a variety of cards that can go in. So this is our low voltage card. It goes to 3 kilovolts, and it's 8 channels. So the choices for you are the 3 volt, 3 kilovolt, 7 kilovolt, 10 kilovolt, 15 kilovolts, and we also have a card here that does 15 kilovolts and 25 amps, but it's 4 channels. That's a 4-channel card. And we have another card for just current for 40 amps and another one for 70 amps. So we give you a lot of varieties. The system is modular. It's customizable. In fact, here's how we customize it. Basically, you give us a drawing of what you want to connect, and we return with a configuration that looks like this, and we basically build this to this your specific requirement. So in this case, what you're seeing is 2 cards, bank 0 and bank 1, and this is terminals 1 through 8, okay? And they're tied to a bus, which can be the return or it can be the sense negative, okay? Now, on the other side, we have two banks. This is bank 4 and bank 5, and they can be tied to either high voltage or sense positive. So if you want that bus to be tied to high voltage, you close that, you open that. If you want it to be tied to sense positive, you close this and open that. So pretty easy to do. Some other testers only allow you to turn on a bank or off a bank, let's say 8 at a time, okay? This here allows you to have individual control, which gives you the flexibility to check each contact to all the other contacts as an example, okay? Now, here's another diagram. This shows you something a little more complicated, but this gives you a feel. There's virtually, we can connect just about anything to anything. You just tell us how you want wired. You give us a drawing, just hand draw it, shoot it with a camera, and text it to us, and we'll return with a configuration like this. Okay, so the overall system, up to 15 kilovolts, up to 70 amps of current, up to 256 points of chassis, 16 chassis. That's a lot of points. That's a big system. Most of our systems are, 20, 40, 100 channels, but we can go up much, much larger. As general benchmarks, figure that it takes about 100 milliseconds per point per test if you're doing continuity. Figure that it takes about 1 second per test if you're doing voltage withstand. That's basically time to, ramp up, stabilize the voltage, make the measurement, and ramp back down again. Okay. So each relay is individually controllable, and you can connect anything to anything. Are there any questions? Can everyone hear me? I'm just trusting that you can all hear me out there.
Yeah, we can hear you. I'll check the chat.
Okay.
Looks like we don't have any questions on chat, so you've honestly answered what they wanted, and hopefully, as we go through the next sections, you'll also get some questions.
Okay,
Anybody
good deal.
doesn't want to open up their mic, give it a second, and go ahead to the next section.
Okay. So I'm actually going to fire up the hardware right now, and we're going to do, I'm firing up the HiPod and firing up the switch, and we're going to go on over to our software. Instead of just using slides, I thought you guys would actually like to see it in operation. This is QT Enterprise, our software, which I really like for controlling the whole system. And what you do, there's a series of tabs on the front: System Configure, Test Sequence, Run the Test, Look at the Reports, and then we have some utilities and administrative tools for you. Okay. So the first thing you do is you come to System Configure, and you tell it, do I want to connect via GPIB or RS-232 or Ethernet? Okay. In my case, I'm using Ethernet. I want to test the interface. That's all I do. I test it. It goes out. It pings the HiPod. It returns with a pass. It tells me that we're good. Now, it's important to hit save after that, because what happens is when you go on over to the test sequence, it needs to have that saved. Okay. So there's also a spot where you can say, yes, in addition to the HiPod, I have some switch matrix units, and you can connect them up here. You basically tell us how many you have, and you tell us how you're connecting. There's a variety of ways to connect to the actual switch itself, and that's all there is to it. Okay. Now, in the test sequence, specifically, there's 3 tabs in here. Okay. So there's the general settings, where you can set things like autosave if it fails or autosave if it passes. You can put in information about the DUT, such as the model number, and you can auto print and if it fails or if it passes. Okay, so you have detail, brief, and a full printed report, so you can determine how much data you need. And so when you do a discharge, as an example, one of the things we can do is limit the current, in this case to 200 milliamps, so that determines how fast you discharge. And there's also some stuff for test information. For instance, you can put in a picture here that tells the technician how to connect up, and maybe shows pictures of the DUT and the model. So this is the set on test steps right here. And when you want to define a new test, all you do is you say new, and then you tell it what type of test. So there's a variety of tests that you can do. You take a look here, and you can see that you can select from DC withstand, AC withstand, DC insulation resistance, ground bond, low ohms, ground leakage, breakdown, switch matrix, you can set it up for the test. Pause basically says wait 1 second or 2 seconds or 3 seconds and then proceed with the test. That may allow the technician to do something. Maybe you don't know how long the technician will take. You can put in a user hold and say wait till the technician starts it up again. And then there's a pulse test, basically for hitting it with rapid high voltage pulses. So you can select any of these. Generally what I do is I start with a switch matrix and I say, well, which points do I want connected? Okay, so for instance, if I want outputs on these channels, that's all I do. Maybe I went right there. Okay, so that is the way you do a test. And then let's see, I should have said new test first. Let me try that again. So there's a switch matrix. You pick the ones that you want, and then you say a new step, and then you pick the type of test you want to do, and say it's DC withstand. You can give the test a name. That specific level of the test can have a name. For instance, high pot the ground. Okay, you can put that right there. You specify the level of the voltage, and you can ramp the voltage. So you can ramp up, maybe the test requires a 3-second ramp up and a 3-second ramp down. You can specify that here. Instead of just seconds, you can say the slew rate in voltage per second. So you can check that off and you can say slew up at 50 volts per second as an example. Okay. When you get to the top, you dwell. And so you can, some specs say 10 seconds. For instance, a production test might only be 1 second, but a qualification test, I've seen some standards that require 10 seconds. You can specify that here. Test delay. So once you get up to the top of the voltage and you're dwelling, this delays, let's say you're on a 10-second dwell, you can delay by 9 seconds so that you make your measurement on the test near the end when the voltage stabilized and you have the most accurate readings. Okay, so those are all controls, and that's what we're able to do. Now, for safety reasons, when we're done with a DC test, we can do an automatic discharge, okay, because you don't want to end the test and have it charged up. So I can set the discharge. I can say discharge at the same rate as we ramped up, or I can say discharge really fast, or I can say don't discharge at all. Now, the reason for that is in case, let's say you're going to ramp up from 1,000 to 2,000 volts, you may not want to go from 1,000 down to 0, then up to 2,000. So we can turn that discharge off, okay? On the measurement side, we can specify the breakdown current. So in this case, we've set 10 milliamps, and what we're saying is if any current happens greater than 10 milliamps, something's wrong. That's a breakdown, okay? Now, if you have a breakdown, you can continue or you can stop. So maybe you don't want to damage the device any further, you can leave that unchecked. But maybe you want to finish the test and see how everything else worked out, you can turn that on, okay? For leakage, we can specify both a lower limit and an upper limit in current. And so you just tell us all the way down to the nanoamps. And the reason why you might want to have a lower current is just in case, say the technician forgets to hook it up. You could conceivably pass every test by just not hooking anything up. So if you know that typical leakage current is maybe just a milliamp or a couple milliamps, you can specify that in there. On the upper end, you specify when leakage is too much and there's something wrong. So we also have specific arc filters and detectors internal, and there's two components to that. It looks at both the current and it looks at the time. So for instance, in this case, we're looking for a wideband arc that is greater than 10 milliamps in current and occurs at less than 4 microseconds in time, okay? So that is how you define the steps. And then after that, all you have to do, I'm going to pick a different test because we're going to do a demo here. I'm going to pick this test I developed for another company. And I just go to the run test sequence, and you notice that it's automatically selected in here. And all you do is you hit run. So I don't know if you can hear the machine back here. But what you, and I'll do it again, what you saw was it just did a 16-step test. It switched and it did DC withstand at 3 kV, switched and did again, switched and did again. And if you look at the switch step, you don't see any results because that doesn't make sense. But if you go to the DC withstand, you'll see that we give you graphs of how the voltage varied over time. We give you a graph of how the current was over time and a graph of the leakage over time. So all of those are helpful for diagnostics and for showing customers, exactly how you performed. So in this, notice that I can put the DUT model number, I can put the serial number, and basically, let's see. So I can run this. Let me run one more time because it happens so fast. I'm not sure you got a chance to see it. And plus, I like running it. Okay, so that's how quick the test can be. Now, even recently we did a test with over 600 channels, and it was basically doing continuity and everything, make sure all the traces were connected, and it was also checking for shorts and then doing a DC withstand test. And the test requirement was the whole thing under 2 minutes, and we did it. I think it must have been maybe about a minute for 600 points. So for production tests, this thing is really, really rapid. So that's the run test sequence. When you're all done, you can come over to reports, and you can take a look right here. Again, you can search for model number and serial number. Look at these different tests that we've run. Most of these have been pretty recent. If I'm interested in this test, I can just click on that, and I can see, oh, it passed. Cool. This is when it was run, and I can save those results as a CSV or a PDF. And I can look step by step. Let's say it failed, or even if it succeeds, I can look and see how each test performed. Okay, so the nice thing about QT Enterprise is you saw how easy it was to set up the test. It's funny because customers come to us and they want to pay us big money to program for the test. Well, you saw what the programming looks like. There's no code. It's really a matter of just selecting what you want it to do. Now, you can pay us big bucks to do that. I'm sure we won't turn down the money, but you can do it, and you can do it easily. And this gives you the flexibility so that you can go in there. Let's say you get a new model number. You can go in there and quite easily just define or alter the test sequence. This test sequence, you do it once, and let's say you have multiple testers out there. You could have many cable test systems out there, okay? So what this would allow you to do is to go on out there and download this test sequence into multiple testers, and then monitor the reports from multiple testers right here. Okay. Now here's some of the utilities. You can download this software right now off of our website. It comes with a free 45-day trial evaluation. If you have one of our HiPots, a 95X or a V7X, you can download it, and it works for 45 days. After that, you just buy it and put in a registration key and validate it here. Okay. So that's utilities. Under admin, so you have a whole bunch of people out there on the production floor or the engineering floor, and some of them you trust and some of them you don't. So you can assign different levels of users: normal users, run-only users, admins. And for each of these people, you can have a different username and password, and you can come over here and give them different rights. So I'm sure you've seen this type of capability before, and it is here for you if you need it. So that's basically how you run QT Enterprise. And let me see. Were there any questions? That was probably a good spot for questions.
Well, folks, I don't see anything on the chat. If anybody's got a question, feel free to unmute your mic and you can ask that. Looks like we're in good shape.
Okay, so we also have a whole bunch of accessories that can go with the HiPod and the switch. One of which I've shown you already is the Enclosure, but we have safety switches, remote start switches, foot start switches. You see that light right there? That's actually an option, but you can order that. And basically what that does is it turns red when there's high voltage present. So that's about it. We look forward to it. No one's asked about pricing, so I'll just tell you that the the V9.5Xs typically are in the $3,500 to $5,500 price range. The switch, the chassis is pretty inexpensive. It's less than $2K for a chassis, and then the cards are, quite often $800-900 per card. So an entire test system that has quite a few points is typically under 10 grand. So it's very cost effective. And I hope that answered your questions. And if you have any other questions, feel free to contact us. We would love to talk to you. Don, I'm going to turn it back to you. Do you have any other parting comments you'd like to make?
No, just put back that last screen there, if you can. So,
Okay.
we really appreciate everyone taking the time. Obviously, we're here to support you throughout the world with any of your questions. You can reach, when you get this presentation, it'll also have the contact info for us corporately, which you can see there, the 858 number, along with sales at Vitrek. Or feel free to hit Glenn or myself directly, or any of our team. Like I said, this presentation will be sent out to you. If you go to our website, you'll find quite a few others. And don't forget, embedded in this presentation are several links that will take you to actual specifications for tests. There's a couple demos in there just so you can see those from tests that we have done in the past. And unless anybody's got another question, just really want to thank you for your time and attention. And hopefully this generated some thoughts, and we're here to serve you whenever your needs are cable testing.
This is very strange doing this presentation like this, because the whole time I'm talking, I'm just hoping people can hear me out there. I don't know if the cell phone disconnects and I don't hear it. So any feedback's appreciated when we do these presentations. So.
All right, everyone. We appreciate your time. Thank you, and be safe out there. And hopefully we get back to normal very soon.
Have a good day, folks. Thank you very much for attending.
Thank you.
Bye.
Thank you.
Thank you.